Okay, hello, this is section 1.10 in Calc survey, and today we'll be talking about periodic functions. Now, this isn't always on the IU curriculum, but we always do it at Carmel, and that way we're prepared either way, and it's good for you to see and be refreshed on your periodic functions. And the nice thing is, in this class, we're only going to do sine and cosine, so I know that makes you upset, but yeah, there it is. Just sine and cosine. And we're not going to get too complicated like you did in pre-calc. All right, so just a reminder, periodic functions are functions whose values repeat at regular intervals. And as you can see in the real world, it's not obviously going to be perfect. I heard recently that if you have a perfect heart rate, that's actually not a good thing. So, but you can see how it relates to periodic functions. Okay. Now, also a refresher, amplitude is half the difference between its max and min values. So remember, that's going to be the middle line that runs through your function. And the period is the same time, or is the time of the function to execute at least one complete cycle. And remember that formula for sine and cosine, well, for all the periodic functions, is 2 pi over b. But you have to also remember in the real world, that's not always going to fit one cycle, but that at least gives you a nice formula to work with. Okay, so here's an example, obviously not perfect, but amplitude is where you're going to find the maximum, find the minimum, and then just like it says, half the difference between the max and min, so subtract, divide by 2. Okay, now you end up getting 1,000. You'll want to add that to your lowest point. So really where this dotted line is actually not correct. You want to add that to your lowest. That should be where the middle line is. So a benefit to watching the video, there is a slight mistake there. So add that 1,000 to your lowest or subtract it from your highest, and that's where the amplitude needs to be when it's graphed. Okay. And then the period is you estimate, obviously on these types of graphs, just do your best. When does it look like it finishes the cycle? I said roughly around 6. It looks like it gets back to 6 or 7. Okay, and just do your best. And anything is justifiable, all right? As long as you have a good argument, I'm always open to a good argument. And then the ionization energy at 40, so any answer with a good explanation. So 40, notice that goes past the graph. So if you were to continue this, what would you estimate to be the value? And again, whatever you have a good justifiable answer, okay? Now, the parent graphs for sine and cosine, I have graphed them here for you. I know you have a very good pre-calculus background from the teachers that you have come from. So just a refresher, amplitude's 1, period's 2 pi. Take that 2 pi, divide it by 4, that gives you the increments to graph. That's what's over here. So you're going up by pi over 2. And then you start at the origin for sine, you start at 1 for cosine. And really, cosine is just the sine graph shifted over, right? Or whichever one you want to argue. Okay, and then let's scroll down here. So some more review. So here's your function, a times sine of bt plus c. Now notice we're not adding anything within the angle here, which is really nice because that's where it got really complicated when you would try to shift that graph, and that would mess up all of your different increments. So in this class, we're going to keep it very basic. We will play around with the period, but other than that, we're going to affect the amplitude. We'll maybe move it up or down, but we're not going to be really messing with shifting it, which is really nice. That takes out a lot of headache. Okay, and then here's your amplitude, and then your period, there's that 2 pi over b, and then a vertical shift is your c. Okay, so write the possible formulas for the following periodic functions, and do the best with what you got. So on this one, if you wanted to say cosine, you could, but remember, we're not going to mess around with shifting it. So the fact that it goes through the origin, we're going to go with sine. And then it looks like it's definitely going down, so we'll need a negative sign. And the period, now, -3, it's a little past -3 and a little past +3. I wonder what number is around 3. Pi. So 3.14. So you can assume that that's going to be a period there. And that's definitely 2 pi. pi plus pi. Okay, so, and then to solve for that b value, once you have the period, then set that equal to 2 pi and you get b equals 1. Okay. Now over here it gets a little more complicated. So it looks like we finish a cycle. I said roughly around 2.1. So I kind of pretended we don't have a trigonometric graph. So go with the data. We know it's sine, it goes down. So there's the negative and the sine. And then it looks like we're only going up to 1/2. So the amplitude is 1/2. And then I just took 0 to 2.1. So made the period 2.1, set that equal to 2 pi over b. Flip those, solve for b, divide, and you end up with 3. So that worked out nicely. So 3x. And then this last one, so this is one that's actually been shifted down. So notice the amplitude is now at -1. But other than that, well, the amplitude is 1. Sorry, it's been shifted down 1. So, and start here, look here at your y-axis, and we're starting off of that middle line there. So we're going to say it's a cosine graph. Nice normal cosine graph with a period of, looks like pi. So I made a period of pi, set that equal to 2 pi over b. B then is 2. And that's where cosine of 2x minus 1 is coming from. If you're confused on these, email me, let me know. Some of you are going to be a little more confident than others. And some of you remember this, some of you don't. And it looks like I gave you a nice website here if you want to practice some transformations. Now, on these next 3 examples, you are just practicing graphing. So you only need to show me 1 period. Make sure you label your intervals. So 3, there's no shifting up or down, but 3 is our amplitude. So I make dotted lines, 3 above, 3 below. Then this is your b value. So 2 pi over b gives me 4 pi. So I'm going to complete a cycle in 4 pi, from 0 to 4 pi. Now divide that by 4, so you get pi. So I'm pi, 2 pi, 3 pi, 4 pi. And that's where I complete my sine. That's how I do it. So here, 1/2 is my amplitude. So this is my b value. So 2 pi over 3 is when I complete a cycle. That's the 2 pi over 3 is when I complete a cycle. So divide that by 4. So I'm going up by increments of pi over 6. I know I have a cosine, and it's just a nice cosine graph starting up top. And then this last one, same idea, but you do shift up 1. So shift first, then go above 2 and under 2 from that middle line there. And then other than that, once you've got everything shifted, this is a normal, sine will complete a cycle in 2 pi. Divide that by 4 if you want, but you guys should know that. Pi over 2, pi, 3 pi over 2, and 2 pi, and then just make sure you start on that middle line that you've shifted up 1, and then because of that negative, you need to go down first instead of up. So you, again, have a graphing calculator sitting on your desk. Use that to help you. I will warn you, there are problems in your homework where you have to write trigonometric functions to fit the scenario. So you need to make sure you do your homework and try that problem that's in your homework that I'm sure we'll be going over in class. Okay? But that is all. Email me if you have any questions.